Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to set up Nakama in C# with Godot. So we're going to go through the process of talking about what Nakama is. We're going to talk about what Docker is. We're going to talk about how to set all of that up. Then we're going to go in and we're going to talk about user accounts and authentication. And then we're going to move into how we can do friend systems. We're going to talk about how we can store data out on the cloud, or at least out on our Nakama server. And then we're going to go and talk about how to synchronize data and actually how to build a small multiplayer game. Now, this game doesn't have all of the bells and whistles of a full-fledged game, but it does have the basis of what we need to synchronize data using Nakama. This is not going to be an end-all be-all tutorial. There will be a part 2, but this will serve as a good foundation to get started. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing we need to do is we need to talk about what Nakama is and what Nakama isn't. So Nakama is a multiplayer library / server that you can actually host yourself for your games. It's created by a company called Heroic Labs, and they have a lot of really cool features and a lot of really cool things that you can use. Now, if you take a look, it's one of the most popular open source game servers out there. So you can see here, it's got all sorts of features. So you can actually come in and do stuff like checking which active matches are running. You can come in and actually store data and store those people's information. So the nice thing about Nakama is it's kind of a one-stop shop for a lot of the stuff that you would normally need to build yourself. So it's really useful for that. Now, if we scroll down, you can see here, it's open source, so you can use it for your projects for free, and there is no royalties or anything like that. Now, that being said, I will talk about how to monetize their product because it is monetized in a way, so just be careful of that. You can see here it has real-time multiplayer and it has competitive multiplayer, so you can actually keep track and actually have a matchmaking algorithm that can actually match people up. Now, I believe you have to code that yourself, but they have a nice guide on how to get started doing that. Now, the nice thing is this is also supported in Unity, Unreal, Godot, C# and Cocos, JavaScript, and I believe Java. So they have lots of different languages that they support that you can actually integrate with here. Now you can see here, here's some of the features: a real-time online multiplayer game. Now, something to keep in mind, this is a engine that runs on a server. That means that if you are going to use this, you need to actually have a server for this to run on. Now, I am going to walk you through how to do it with DigitalOcean, but just know that this is a thing and it is important to remember. Now, something that's nice about this is a server-based networking solution, not a WebRTC solution. So it's not peer-to-peer. It's going to be build a lobby and it's going to route all the traffic. So that's something to keep in mind. So the hosting costs could be a little bit higher if you're going to allow that. That being said, I will do a follow-on that will talk about how to make this a WebRTC based connection, and then you can get rid of that little bit of hosting cost. And you'll still need to host the game, but it'll be a lot cheaper. You can do stuff like having a leaderboard, you can have tournaments, you can have leagues and seasons passed all built in. They have a virtual wallet, so you can actually keep track of all the in-game currencies and things like that that you want to sell to your people. They also have the ability to validate in-app purchases. So if you're using Google Play or Steam to purchase different assets, you can actually validate those in-app purchases right here inside of Nakama. They also have the ability for you to have player profiles. You can have friends and persistence. You can also have communication between people, and you can actually alert players with in-game notifications and have a real in-game chat. Now, I may not cover all of these features just because there's a lot here and it's a huge thing. And this tutorial would be 12 hours long if I covered everything. So just remember, I'm going to give you a brief brush and then we can go in deeper as we want. And finally, you can extend the actual game server using Go, TypeScript, or Lua. So the nice thing about that is that you can define your own stuff. So you can actually build your own things to make your server whatever you want. Hey guys, Editor Mitch here. So something I forgot to discuss was how Nakama actually makes money. So this is an open source tool and it is 100% free. You can use it for your game forever and it never costs you money. However, they do make money by hosting it for you. So if you host it on something like DigitalOcean, right? Something like this where they have their own pricing, right? Or you drop it onto like your own server or something like that. It's 100% free, right? At least on the Nakama side. Of course, the server would cost money if you're going to host it on a cloud service. But the way that Nakama makes money is by using their own heroic cloud system. So it's extremely expensive and it's really not worth looking at until your game becomes a gigantic game, right? So like we're talking thousands and thousands and thousands of users, right? You can see here, you can see 1 or 2 CPUs, things like that. You can see right here how much having them host your stuff is going to cost. $1,000 a month, right? Like let's say you have a machine that has 2 CPUs and 2 database CPUs, then you're looking at $1,200 a month. And you get a lot of benefits for that, right? Automatic system scaling, an enterprise edition of Nakama, which means that Heroic will actually work with you and they'll, support you in your game, and they make sure that everything is perfectly secure. They make sure that everything is scalable. They make sure that everything is load balanced. So let's say, you have a big influx of users. Suddenly, if you've ever seen some smaller game studios where suddenly the game becomes popular and then the servers start crashing and start having problems, well, with this, it doesn't happen, right? It just handles it and we're good to go. So a lot of times that's where Nakama actually makes their money, is by having you pay them $1,200 a month to use them as a resource to host all of their stuff. Now, again, if you don't use them as a resource, it's totally fine, and it's going to be 100% free as long as you host it on some kind of machine you own, or, of course, whatever the cost of, a DigitalOcean machine or an AWS machine or an Azure machine would cost. So that's just something to keep in mind. I wanted to make sure you guys were aware as like a full disclosure so you're not confused as to how they actually make money. So with that being said, let's go ahead and jump into setting up Nakama. So this all sounds really wonderful. Where do I even begin? Well, that's where Docker Compose comes in. Docker Compose is a way to get Nakama running up really fast. Now you can see here, right here, prerequisite, you need to install Docker Desktop. And I'll explain what a Docker Compose is and how the file works and everything in a minute. But just know you need to install Docker Desktop. I have a link in the description of where you can download and install that. But Docker here is a really great tool that allows you to basically containerize applications. And I'm not going to go into like the really nitty gritty on this because there's so much to this that it would take a whole tutorial on itself just to talk about Docker. But what you should do is you should download Docker and download the Docker Desktop. If you click on products, so right here, and go to Docker Desktop, right here, you could just click download for Windows, download for Linux, or download for Mac. So we'll click download for Windows, and we'll go ahead and download this for Windows. Now I already have it installed, so I should probably uninstall it. So I will be right back. And once it's downloaded, we'll go up here, we'll click on our installer, and we're gonna let that install. Now it's probably gonna ask me for permissions, which it did, so we'll approve it, and you will see that this is gonna pop up. Now you can see here, use WSL2 instead of Hyper-V, recommended, absolutely. and add a shortcut to desktop. So let's go ahead and hit OK, and you'll see it's going to unpackage the files. Now, what this is doing is it's basically saying, okay, we're going to install Docker, right? We're going to put that all in. But the question is, what is Hyper-V? What is WSL? And what is AMD-V, right? So how all this works is basically Docker works. Think of it kind of like a container ship, right? You have all of these big containers on top of this ship, right? And each container contains an application. That's why they call it a Docker container, is because it contains an actual application that's running. And it also contains the OS that's built into it as well. So it's kind of like a virtual machine almost. Now, just below that is what's called the Docker engine. And the Docker engine can run in two configurations, the Hyper-V configuration or the WSL configuration. Now, the advantages and disadvantages of either one doesn't really matter. Typically, WSL is a little bit faster because it's Linux, but it doesn't really matter. Just know that it's running on top of that stack, if that makes sense. If it's running into that as like a virtual machine or as like its own thing, if that makes sense. It's like its own process. And then it runs on your host OS, which in this case, in my case, it's Windows. So everything's just put onto Windows. And then outside of that is your hardware. So that's kind of how the layers work with Docker. And the advantage is that you can spin up applications really fast and you can shut them down really fast. So it allows you to do what's called scaling horizontally to make your products more efficient. Think of it kind of like this. If a bunch of people are in your game and suddenly your server starts to get overloaded, what you can do is spin up another server and then load the Docker image on it and then just hit run. And then suddenly, bam, it's running that actual server exactly as you configured it, and everything is just builds up and it's done. So it's really, really fast. It's really efficient. And it's also great for development because it allows you to have a nice sandboxed environment for your stuff to live in, which improves security and stability for all of your products. So it's just something really good to get used to and to know. And it's something that everybody is using in the industry. So just keep that in mind. Now, once Docker Desktop is installed, we'll click close, and then we're going to type Docker to open it up in our start menu. So it'll probably pop up. I expected it to pop up in the upper left-hand corner, but this time it popped up right here. So this is a subscription service. This basically just says, hey, this is a free thing, but if for whatever reason you make $10 million or you have 250 employees, then you should purchase the product and use it for that. Most of us are never going to have this problem, so I wouldn't worry about it. So we'll go ahead and click accept. Now, once Docker comes up like this, you can just hit continue without signing in. That's fine. It does not matter. And you'll see it's going to give you a welcome survey, and you can put whatever you want. In my case, I'll just say, I don't know, I'm a backend developer. May as well. And then it's going to say, what will you use Docker for? I don't know, testing applications. And then we'll go ahead and hit continue. Now, this is what Docker looks like. So you can see here you have containers, images, volumes. Now, I'm not going to give you a crash course on how this all works, but basically containers are your applications that are running, built or running currently. So you can always shut them down and start them up from here, no problem. If you see an image is basically a version of a container. So it's a thing that you can reuse and respin up new containers. So think of it kind of like if you have a class, right? And you have a bunch of stuff in this class, and then you inherit from that class, right? You get all of the properties of that class, and then you kind of expand on that class, right? And if you spin up another inheritance from the original base class, it gets all of that additional stuff. That's kind of what an image is. It's the base class of your containers. Now, that being said, you want your base image to be almost as close to your actual final image as humanly possible, just because it's a lot simpler. Volumes are basically used to store data. So don't worry about that, but it's basically just where all your data is stored. The nice thing about this is when volumes exist, that means that you can reuse them. So if you were to duplicate a volume, it would duplicate all of the storage that's associated with it. And you could also point multiple containers to one volume and share storage between containers. So that can be useful if you had a server that had 5 instances up and it all points to the same storage volume, it would all share the same information. Now, that being said, there's a lot of wrinkles with that, but just know that that's a thing and it does exist. Builds, I never use this, but it's basically building different containers and different stuff like that. So I never use it, but it's a thing. And then Docker Scout is basically just an advanced analytics system that's built into Docker. And now let's talk about compose files, Docker compose files. And now let's talk about Docker compose files. So if we head out to Nakama here, you can see here they have a docker compose.yaml file here. So if I just grab all of this, I'm going to copy it. Now in my case, I'm going to grab the Docker compose first one, which is the cockroach database. And typically, if you're going to be using it in production, you might want to pull the Postgres one. That's this one down here. But since this is not going to be used in production, this is just for my own local testing, I'm just going to use Cockroach. It's a lot smaller database. It's a lot easier to work with. So we'll go ahead and just grab this entire thing here. We'll copy this guy like that. And then we're going to go out to a folder location. So I will go right-click File Explorer, and I'm going to go into my documents. Now, inside of my documents, I'll just pull this guy over here. We're going to right-click, add a new folder, and we're going to call it Nakama server. And in my case, I'm going to add tutorial. And you don't have to if you don't want to. Now we're going to double click on that. And we're going to click up here. We're going to type CMD. And then it's going to open up a command prompt. So I'm going to type code dot. And that's just going to open up Visual Studio Code. Now it's going to make it gigantic. There we go. And basically what Visual Studio Code is going to be used for is it's going to allow us to edit files. So we're going to hit new file. We're going to make a text file. We're going to paste this YAML file in. We're going to control S and we're going to name it Docker. I believe it has to be lowercase d, if I remember correctly. If we take a look, it's docker-compose.yaml. So we'll go ahead and just grab that Docker compose YAML and we'll hit enter. Now, this is a Docker file. You can see there's all sorts of information in here. And I'm not going to go too crazy in depth in it, but just know that this is a thing, basically. So what it is doing here is it's creating a service named CockroachDB. It's pointing out an image for Cockroach. So here you can actually control what version of Cockroach you want to use. You can see here it has a command that it's starting. So when the actual container starts, it's going to run this command as an argument. You'll see restart no. That means that it's not going to reboot it. Volumes, it's going to create a data storage volume. It's going to expose these two ports in the firewall, which is the HTTP port and the actual Docker port, Cockroach port. And then you'll see that we're mapping those ports to our own internal ports. So our actual Windows system is getting mapped to these. And then you can see that they have a health check as well. So we can actually come in here and we can go to this address right here and it will check if it's up and running. And then you'll see here that we're doing the same thing but with a Nakama one. So you can see it does all the things. It does a health check. And then Prometheus. Now, Prometheus is a open source metrics and monitoring solution. So you don't technically need it, but you should have it for all of the Nakama graphs and stuff like that it actually uses. So I would keep this, and it's very nice to have. So we'll just put that there. So once you have this, you can save that Docker Compose file and open up your command prompt in that location. So you can see we're in the C users FindPoint CGI documents, Nakama server tutorial, and then we're going to type Docker Compose. Up like that. And we'll hit enter. And what that's going to do is it's going to download and pull all of those images it's looking for and all of the data it needs. And it's going to pull down all the Cockroach and Nakama and everything and get it all set up for us. And then in a minute, it's going to create all of the stuff and it's going to fire it up. And you'll see that it has fired everything up successfully, or at least it's getting there. It takes a little bit longer the first time. So you can see here, it's now done. So you can see we have a startup done message right here. If we open up our web browser here, and we go to 127.0.0.1:7351. If we hit enter, you'll see we have a Nakama console here. Now, the username is admin and the password is password. Now, you probably should change that password when you're ready to deploy this, but in this case, it's totally fine just for monitoring and stuff like that for it to keep those passwords. Now, you can see here, there's all sorts of stuff inside of Nakama, and unfortunately, I'm not going to be able to go through everything. There's just so much here that in one tutorial, it would take way too long. But you can see here that we have a status, which is node name Nakama1. So this is really good for clustering. So Nakama actually offers clustering, which is really cool. And basically, you can tell it to coordinate different clusters and throw people on different sessions and things like that. And that's a whole other ball of wax that we're not going to be able to get into. They have a process latency, a rate, an input, and an output. So this is how much data it's actually using, what the process latency is, what the input, what the output, and stuff like that is for that actual Nakama instance. If we go over to user management, this is where all of the user management stuff is. So you can see that you can actually build users for your project. So you can come in here and say, hey, I want to have an email, a username, a password, and a role of some description. Now, I'm not going to create any more users just because there's no need to because I have the admin role, but this is useful if you want to create a smaller subset of different accounts for your maintainers. So for people who are developers or maintainers or something like that, this is very useful. For the most part, if you're doing a small project, this is not going to be necessary for you, but it's something that is useful. Now you can see they have a configuration section. So this is where you change all of your configuration. So you can come in here and actually export this out and then re-import it and then change the configuration. So if you click on export right here, and I just drop that on my desktop really quick, and I open this up, I drop this guy in and I open it up. You can see this is your actual Nakama configuration. So you can do all sorts of stuff like changing the tick interval, the different IAP stuff if you have an IAP. So IAP is like Google Authentications and stuff like that. You can change your username and password right here inside of your login. You can come in here and change what type of runtime, where the runtimes are located. All of that is right here. So you can go through and change any of this. And if you go into the Nakama console, you can actually just put it right back into here, browse it out, and then drop it in. And it'll reboot all of your Nakama and take all of this into account. Next is runtime modules, and we will get through that later, but basically the concept is it's all of the extensions to your Nakama instance, and that's basically what this is for. So it's all of the special stuff that you need. Like if you want to list all of the ongoing matches for your users to see, you would build a module to do that. Accounts is where all the accounts live, so these are all the user accounts. So these are the accounts of actual people that are playing your game. So user management and accounts are separate. This is for management of your Nakama instance. This is for management of your game. That's how it's separated. So this is actually where user accounts will live. So you can see if you click on here, user ID 00000, display name, avatar, username, different types of authentication, what friends they're a part of, what groups, what wallet they have, so what kind of money they have, what purchases they've done, what kind of software subscriptions do they have, if any, and what kind of storage objects do they have that's associated with their account. All of that is really important. So it's just something that we're going to have to keep track of, and we'll run through these as time goes on. Next up is groups. So that's all your groups and group storage and group information. So don't worry about that. Storage is where all of your data is stored. Leaderboards is where all of your leaderboard information is. Chat messages is where you can see all the different chat rooms and the information that's been sent. Matches is all of the active matches that are currently running. And API Explorer allows you to explore the API and actually do different things within Nakama as if you are an actual application. And that's basically everything that you need to know about this management console. Now, I know I did a really brief overview, but as we integrate it into Godot, we will actually come in here and talk about the different features and why they're useful. Now that we've talked about a lot of the Nakama stuff, let's talk about a little bit of Docker here. So I just went through this earlier, but if you look, you can see here in your container section, we now have stuff in our little Prometheus, Cockroach, and Nakama service tutorial image here. If you take a look at the images, it's the exact same thing, Cockroach DB, Prometheus, and Heroic right here. So it shows that it automatically created all of these different volumes and all of this different stuff for us already. And if we click on some of these, you can see that we can load up that actual image here. Well, in this case, it's a container. We can load up the container here and we can scroll through its console. So it's really nice for like debugging and things like that. So that's something to keep in mind. Now that we understand the basics of Nakama and Docker, let's go ahead and integrate it with Godot. So let's make our project and we'll go from there. All right, now that we're inside of Godot, the first thing that we need to do is we need to create our client. So we'll go ahead and click on 2D scene. We're going to right click, attach a script, and we'll click GD script and we'll change it to C#. Now we're going to name this as Nakama client.cs, and we'll go ahead and create that. Now it's going to open up Visual Studio Code. Now if you're using Visual Studio, that's fine, go ahead and use that, but I'm using VS Code because it gives people who have Linux or Mac the ability to follow along with the tutorial. So the first thing that we need to do is we need to actually install Nakama. So to install Nakama, we need to go into the 3 dots up here, go to terminal, new terminal, and we basically need to install it. So we could type .net add package Nakama client, like that, and it's going to go ahead and install that Nakama client. Now I've already had installed Nakama before with some of my testing stuff, so it's going to be a little bit quicker for me, but that's totally fine. Now once we have our Nakama package installed, which you can actually see here in the Solution Explorer, which by the way, if you don't have a Solution Explorer, then you need to download the C# add-on pack for VS Code. But you can see right here under packages, we have Nakama now, and we can actually type using Nakama like that, and it actually shows up. Now, the first thing that we need to do is we need to actually connect to Nakama. So we need to create what's called a Nakama client. It's basically a way to configure your system so that it can connect to Nakama. So what we'll do is we'll say var client is equal to new client, and we'll pass in the type. So we'll say type HTTP. Then we need to put in the IP address. So we'll hit quote 127.0.0.1 because that is the IP address of our Nakama client right here. So you can see right there. And then we need to put what port we're going to be in. So the port that we're going to use is going to be 7350. And I get that from the configuration. If you scroll down, you'll see somewhere in here, it's been longer than 5 seconds. It's right here. So socket.port right here. So that's the port that we're going to be using to make our connection is 7350. And then finally, we need to come up with our key, which in our case is going to be default key. And that'll be the key that we're going to use. It's going to be a lowercase k. And there we go. So this is going to actually create our connection. Now we need to actually configure a timeout, right? So when you create your connection to Nakama, you need to have some kind of timeout. You need to say, how long am I going to wait before I need to re-authenticate? So we'll go client.timeout is going to be equal to, let's do something like 500. That's 500 seconds. That's a long time. It's going to give us a lot of time to be able to work with what we need to work with, but you can set that to whatever value you want. Now we need to go ahead and authenticate with Nakama. Now there are multiple ways to authenticate with Nakama. You can go through Facebook, you can go through Google, you can go through Steam, you can do a custom authentication, you can do a device authentication, and you can do a email authentication. I mean, there are so many different ways to authenticate, but the ones that we're going to cover is just device and the email authentication. So what we'll do to do our device authentication is we'll say var session is equal to await And you'll notice that it made our ready function asynchronous. So this is a big problem because Godot does not allow you to do asynchronous connections like that. You cannot do asynchronous ready statements. It doesn't work. Godot doesn't like that. So what we need to do is we need to pull this out, Control X this, and say private void ready async like that. And then we can just call ready async like that. And then we can make this asynchronous. And that will basically work. It's just something weird that Godot doesn't like, and I understand, but it's just a thing that it doesn't like. So we'll make that asynchronous, and then we'll say await client dot authenticate. And you'll see there's a bunch of different ways to authenticate. So in our case, we're going to go ahead and do device. So we'll click on that, and then we'll pass in an ID. Now, the cool part about this is that you can pass in a very basic ID, whatever type of ID you want. So I'm going to go with os.getUniqueID. Now, this is not going to work if you want multiplayer and you want to test multiplayer locally because your IDs will be the same. So that's something to keep in mind. So I'm just showing you guys this, and we'll transition to email authentication later. But just know that this is a way that you can authenticate with your device. And now what we'll do is we'll hit gd.print, and we'll print in our session token. So we'll say authenticated. So I'll put $, authenticated with session token, and I will pass in my session.auth token like that. And now if we go out to our Nakama instance here, hit Control S, and we name this test scene like that, we can go ahead and hit play. And you'll see in a second, hopefully, if everything built correctly, it does. You'll see authenticated with session token, whatever, right? This session token is really cool because you can actually use this to re-authenticate if you want to later. And we can cover that in a future tutorial or a later time. But this is something that's actually kind of useful. Now, if you take a look at your Nakama console and you go to user management, or I guess it would be accounts, you can see we have a user account right here. And that's how you authenticate with your user device identifier. So this is really cool, but how do we actually do regular login, right? Like username and email. Well, that's actually relatively simple as well. If we right click, add a child node, let's add in a panel like so. We'll go ahead and make it about this big, give or take. It's probably a little bit too big to be honest, but it'll be fine. We'll right click, add a child node. Let's add in a line edit like so. We'll go ahead and put this guy over here. And then we'll duplicate it, bring it down. We'll right click, add a child node, and let's add in a label like so. We'll put user name like that. We'll put this down like so. And then we'll duplicate that label. We'll bring it down and we'll say password. There we go. Now, once we have these two, that's going to be where the players are going to put in their information. And then we'll add in a submit button. So we're going to right click, add a child node. We'll add in a button like so, and we'll make it about this big. Now this might be fine, and we'll type submit like so. Now, once we have this, we'll go ahead and default this to test@gmail.com, not com like so. We'll come in here and we'll put this as password. Now, if you want to hide the password, you can actually do that in here under secret. You click this and that'll hide it, right? Now, in our case, I'm going to leave it just so you guys can see it. But the reason why I'm doing this is so that way we make it a little bit easier for us in the future when we're doing our testing. We're going to have that stuff auto-filled in so we don't have to deal with that. Now, I'm going to come in here. I'm going to name this as user name. I'm going to name this as password. And I'm going to come in here and name this as login panel like so. And then I'm going to come into my submit button, node on button down. We'll name this login button like so. I will double click that, right, Control A, Control C, connect it. It's going to pop up our editor. We'll say public void paste like that. And that's going to go ahead and create that little function right there. Now, in order to log in, let's go ahead and comment this guy out because we don't need to authenticate anymore. So in order for us to log in via email, what we need to do is first we need to create our session variable. So var session is equal to await client, and you'll see that client doesn't exist, right? That's because we made this a private variable. So let's go ahead and make that a variable that goes across our entire class here. So we'll say private, not that, private client, and there you go. And then we'll come in here and we'll just say client is equal to new client. And then we can come down here and say await client dot, and then we can go authenticate email async, like so. Now we can pass in an email and a password. So the email we're going to pass in is going to be get node, and it's a text edit, if I remember correctly. Let's double check real quick. It is a line edit, not a text edit. So let's go ahead and go back. So it's going to be a line edit. And then we have to path out to where we're going. So in our case, if we pull this guy over just a tiny bit, we can take a look. We'll get rid of that real quick. We're not going to get out of this little area for a while. So we need to go to panel, login panel, / username dot text, like that, comma, and then we need to do the same thing but for our password. So we'll just grab all this code, copy it, paste, and I'm going to hit enter just so that it kind of organizes a little bit easier, and we'll say password, like that, and we'll put a semicolon like that, and that's going to authenticate us and build us an actual session. And now I can grab this guy, copy it, and paste it. And much like what we did with our client, we should probably do the same thing with our sessions. So we'll say private, and you'll see what this comes back with is a I session. So we'll say I session, like that. And then we'll burn that right there. And that will basically hook all this up. Now, when we print out our authentication token, it should just work. So we'll refresh and we'll click submit, and you'll see authenticated with session token, whatever it is. So now if we look at our Nakama console here, we hit refresh, you will see that we have another user right here. Now, what if we want to add in a user name when we actually authenticate? Well, we can do that by either updating the user information or by just passing it in right here. If we hit comma, you'll see all of these different things. So you can see username is equal to null, system collections generic, retry configuration, and then a cancellation token. Now, what we can do is we could just pass in, if we just grab our email right here, like so, and then we can just say dot split, like so, and we could do our separator is going to be the at, and then we could just go bracket 0, and that'll basically pull back that first element as their username. So in this case, if we go ahead and try this, hopefully this will work, because this is all off the cuff on my mind, right? So we'll see. If we hit submit, you'll see it authenticates, and then if we come in here and we refresh, well, it didn't seem to work, so I guess that's not a thing, which is unfortunate, because I was hoping that it would pull back the first element and just show test, but I guess that's not gonna work, but that's okay. So what we could do is just pass in quote test, like so, and this of course goes with any username, right? You don't have to hard code a username, but it's something that I'm showing you guys that we could just put like username and then submit that information. So if we come in here, let's see what happens if we go to accounts, we refresh. That's interesting because it doesn't seem to actually work. So I wonder if that function just doesn't actually work. Or is it because the user already exists? Let's try doing this. Let's go back to what we had, and then let me pull the usernames out. Maybe it's because it already exists. So I'll delete both users. And then we'll come back here, we'll refresh, we'll try this one more time, and let's just see if this works. So we'll hit submit, we'll come in here, we'll refresh, and there you go. You'll see the username is test. And the reason why this works is because what we're doing here is we're splitting our text by the @ sign. So we're taking something like test@gmail.com, we're making it into test@gmail.com. And I'm just pulling back that first element and I'm displaying it. And that's basically how that works. Now, of course, you don't have to do it this way. You can actually just update the user's information as well. And in order to do that, it's actually relatively simple as well. When you update your user's information, all you need to do is come down here and create a function. So we'll say private void update user info, like so. Now this update user info, I'm not worried about adding anything to it. I'm just going to hard code it. And you guys can figure out the way to actually go in and make it extendable and usable and all these things, because I don't want to go through the process of doing all of that. And we'll come up here, we'll hit enter, enter. And in order to update our stuff, we'll just type await client dot update account async. And I'm not going to go through and make it super extendable. And the reason why is because I don't feel like we need to. You guys can go in and make it extendable and make the different UI elements for them to update and fill out. But in this case, I'm just going to do it really quick and show you guys how it works. First things first, we got to pass in our session. Remember, our session houses all of the information that we need to communicate with Nakama. So we'll type session, comma, and then we need to pass in a username. So I'll pass in test, comma, display name. We'll type test display name, comma, if we have an avatar URL, which we don't, but I'll type http://test.com/test.png, right? We can hit comma. Language tag, we'll type EN because that's the United States English. Location, US, let's say. And of course, these values are all whatever you want them to be. You don't have to necessarily use them for language information or for time zone or anything like that. You can actually just put whatever you want in there technically and it will work. But I'm just following their standard, which is it's a time zone, right? So EST, right, for Eastern Standard Time Zone. And that's primarily all we need to pass in. And now you'll notice that when we run this and we hit refresh, we'll hit submit, and then we'll come to Nakama. And then we'll click on our test, and you'll see that we have our user ID, our username, test display name, here's an avatar URL, location, time zone. And that's the beauty of this system, is it's really simple to basically put together and use, if that makes sense. Now that we have some kind of login system, how can we actually do a lobby system, right? Because one of the big things that's important is being able to actually build out some kind of lobby, right? So players can play together. So enable to do a lobby system, we're going to right click add a child node. We'll add in a panel and we'll go ahead and put it right about here. And we'll go ahead and right click add a child node. We're going to add in a button, and that's going to allow us to create and join a lobby. Now, when it comes to doing a match, we need to have some kind of name for that match. So we'll add in a label and we'll go ahead and add in a line edit like that. Now we'll put the line edit over here. We'll make it about this big, give or take. We'll grab the label. We'll put it over here. And we'll call this name of match like so. I'm going to go ahead and kind of pull this guy over right here. I'll grab this button. I'll put it like this. And then I'm going to duplicate this button and we'll put it over here. And the reason why I'm doing this is I'll show you guys in a little bit, but basically one is going to join the actual lobby and then the other one is going to actually ping the other user when two people are joined. So we'll go ahead and come in here and say join. We'll come in here and we'll type ping. We'll also type ping for this and join for this. And then we'll go ahead and attach these guys. Now I'm going to make this a touch bit bigger because I'm going to do matchmaking as well. And then at the end of the tutorial, we'll add in the ability to have a multiplayer game. Like it'll be something really small, being able to move characters around and things like that. So when we want to join a match, we'll go ahead and click on our join. We'll click on node. We will double click on that, copy it, and then connect it to our node 2D. We'll come up here and type private, or public, I should say, void paste bracket like that. And then in order to join an actual match, all we have to do is basically pull back the name of our lobby that we're going to be creating, and then we have to create that lobby. So first thing we need to do is we need to create a socket. A socket is basically like a connection that allows us to send information to Nakama. So a lot of this stuff is doing like authentication and things like that. That's all done through HTTP, right? So it's like a web link, almost like an API request. Whereas here, we're going to do some more real-time data. So we need to actually create a socket. So I'm going to come up here and say private iSocket socket like that. I'm going to come down here and I'm going to say socket is equal to socket dot from, and I'm going to pass in my client information. And that's going to go ahead and create a socket. Now we're going to need to connect our actual socket. So I'll say await socket dot connect async, and we need to pass in our session. So I'm going to pass that in real quick. Now you'll see that we have other things in here. So appear online, connection timeout, string language en. These are all things that are useful, so you can choose to appear online. So say, hey, I'm currently online. This is a available socket connection, basically. By default, it's false. We can just leave it that way. Connection timeout is 30 seconds. So if we don't do anything with that within 30 seconds, then it can cause some problems. So we'll make sure that we keep that socket open. Now, once we have this, all we need to do is create our match. So we can say var match is equal to await socket dot create match async, and then we can pass in a string. Now in our case, we're going to get our node as a line edit like that, and then we'll pass in our line edit. So if I take a look at our stuff here, it's going to be multiplayer matchmaking like that. I'm going to grab this, copy it, and it's going to be under line edit. So we'll call it lobby name. There we go. So it'll be matchmaking slash lobby name. So let's go in here, matchmaking slash lobby name like that, dot text. And there we go. So we will have connected to our match. So now we can just type gd dot print created match with ID, and I'll pass in a $sign here, and I will go bracket, and I will say match.id like that. And then I'm going to go ahead and join that match. So await dot socket dot join match async like that. And I'm going to pass in the match.id. Now, what we should do is we should probably make this into a value up here, so that way we can actually reuse it. So private match, and I believe it's a match. Let's check what the thing comes back as. It's going to be a iMatch. So we'll do iMatch match like that. And we'll come down here, and instead of doing var match, we'll just say match is equal to await socket. That's going to allow us to access our match anywhere inside of our script, and it's going to make things a little bit easier for us when we start sending information and things like that. So once we join our match, let's go ahead and say gd.print $quote joined match with ID bracket match.id like that. Now, once we have this, we can go into Godot here, hit save, refresh, type test, join. And it didn't work. And the reason why is because we didn't actually connect. So submit, then join. Created match with ID blah, joined match with ID blah, right? You can see right here, it worked. So if we head over here and we go to status, you can see we have 2 presences and 1 session. So we actually have what we're looking for. You can see our RPC call happened and it did fire off and create our match. You can actually come into matches and you can see here's our match with 1 person in it. So great, it's working, right? So now the question is, all right, how do I get 2 people to join the same match? And how do I send data between them? Well, thankfully, joining the same match is really easy. It's actually pretty much cake. Let's first default this to test so I don't have to type test every 10 seconds. So we'll come in here and default that to test. That way we could just have a match name test. And then let's go to our ping and let's go ahead and connect that to our node 2D. I'm going to come down here and I'm going to say public async void paste like so. And then I'm going to go ahead and set up our ping code. Now, pinging is actually really easy. Inside of Nakama, all you need to do is you need to encode your data into UTF-8 or really whatever encoding you want it to be. And then you need to send that data over. So we'll say var data is equal to encoding dot UTF-8 dot get bytes hello world. And then we want to send that data across. So await socket dot send match state async, and you'll see that there are multiple things here. So first things first, match ID. So match.id. So we're passing the data along with our match. Now we have this thing called an ops code. So what in the world is an ops code? Well, an ops code is not required, technically speaking. But what it is it's a way for us to be able to denote what that data is. So think of it kind of like this. If you were to set this up correctly, you could say 1 is equal to match information, 2 is equal to player information, let's say, right? And in your code, which we'll build in a minute, you can kind of define what those things are. So in my case, I'm going to pass a 1, comma, and then we can pass in our data. So I'll pass in data like that. And that's all we really need to do. And now we need to actually receive that data. So we're sending the data with this. So how do we actually receive that data? Now that's where the code gets a little bit weirder. So first things first, we have what's called a match presence and a match state, okay? And that's handled by your socket. So we'll come up here to our socket on our join and say socket dot received, and you can see we have different stuff here. First, we'll say received match presence plus equals on match presence like that. And I'll hover over this, hit quick fix, generate method, and that will generate this method. And then I'll type socket dot received match state plus equals on match state like that. I'll hover over this, quick fix, generate method, and that will build out that method for us. Now, the beauty of this is match presence and match state are 2 different things. Match presence happens whenever a player joins the actual match or leaves the match. So what we can do is we can come in here and say gd.print at event.toString like that. And that'll just print that out. So that way we just have that. We can mess with that later when we start doing our actual multiplayer code. But for right now, we'll just do it like that. It's going to be nice and simple. So when it comes to on match state, though, this is where things get interesting. So what we can do is we can come in here and say string data is equal to encoding dot UTF-8 dot get string state dot state like that. Now you might be asking, okay, hold on, why is state dot state a thing? So you can see here it's a byte array of data. So down here, when we send our match asynchronous, data becomes state up over here. It's the state, right? So it's the data that it's getting sent across. And then we can come in here and print out that data. So gd.print $quote from user, and we can go bracket bracket data like that. And now if we go ahead and we hit like this, go back to Godot, we click Control S, and then we go ahead and fire this off. Well, first things first, it's not going to work because I just forgot about this. We need to actually run 2 elements. So we'll go to multiple instances and we'll run 2 instances. We'll go ahead and hit play. And then we'll come in here, submit. So we'll log in with 1. We'll hit test number 2, submit. We'll log in with number 2. And I got a debugger error. So username is already in use. That makes sense because if we stop this, I have a user name that's already named test. And since I'm doing test 2, I guess that makes sense why it's broken. So let's go into here. Let's rip that little bit of code out. If you remember right here, we set our username. So let's basically just grab this bit here. Let's copy it, not cut it, copy it. And then let's come in here, paste it, and then there we go. Now, when we want to do our game here, we can go ahead and hit play. And then we can go submit, test 2, submit. There we go. We're both connected. Join and join. And you will see that we've both joined. You can see that we have a match presence event that says username is test2. You can see we have another event here as well that basically says test2. And you can see we have the username test as well. So we have our connections. And the reason why it shows test2 twice is because the server receives it and the client receives it. So both players receive that data, if that makes sense. So now we need to come in here and then we can go ping. Receive data from user hello world. And if we click this guy, same exact thing, received data from user hello world. And you'll notice that if we go to Nakama and we refresh, you'll see that we have a match which has a presence count of 2. It is not an authoritative match, but that's fine. If we look at our status, it should show the data coming across once it refreshes. In about a minute, you'll see a big spike of all the users. But the fact of the matter is that it is actually working. So that's good news. That means that things are actually being done. That's pretty much how you do communication between the two. Now the question is, how can we do matchmaking within Nakama? So let's go ahead and duplicate our little button here. Let's disconnect it. Let's just say start matchmake is what we'll call it. And I'll hit Control A, Control C. I'll drop that bad boy on there like that. Start matchmake. There we go. We'll just throw it like that. We'll go ahead and do on button down. I'm going to Control A, Control C, and connect that. So in order to do matchmaking, all we need to do is we basically need to do the same thing that we're doing up here with our on join button down, but instead we can go public async void on matchmake button down. And in order to do matchmaking, first things first, we need to kind of come up with what we're going to do. So we'll say bar query is equal to quote, and we can put what kind of query you want to do. So you start with plus, and then you could put something like skill level, skill colon greater than 50, let's say, space mode colon deathmatch, like that. And then you could do something like let's create, and then from here we need to create our own numeric property. So they're going to be properties. So basically they're properties that we can use to tell Nakama what our matchmaker lobby is actually going to be. So we'll say var string props is equal to a new dictionary, string comma string, like so. And then we'll add in a single string property. So in this case, we'll go mode deathmatch, like that. And then we'll do the same thing, but for numeric properties. So numeric props. And instead of string, we'll do string double because it requires it to be a double. And then we can come in here and type skill, and we'll make our skill 100, like that. So what this is doing is it's saying, here's what we're looking for, okay? Here's what we have. So we are a deathmatch game, and our skill is 100. And from here, we can actually make what's called a matchmaker ticket. So we can say var matchmaker ticket is equal to await socket dot add match async query, comma, and then we have to tell it how many players we want. By default, they do 2, and I believe it's 8. So we'll say 2, 8. And then for the properties, so it's going to give us a string property. So string props, comma, then our numeric props. So numeric. And then we have our count multiple, which is by default null. So we'll leave that as null. Now, when a matchmaker happens, we need to set up our on matchmaker matched. So when a match happens, it's going to fire off an event, and it's going to say, hey, this is the event of that matchmaker. And what we can do is when a matchmaker is made, we can just come in here and say, okay, once we have that, so we'll say socket dot received matchmaker matched plus equals, and we can basically just create a function to handle that. Or if we want to be super fancy, we could actually run an async matchmaker matched like this, and we could do a pointer and do await socket dot join match async, and then do matchmaker match dot match ID like that. Now, this is always really confusing to people because I'm doing like an inline function, basically, like when this event fires off, do this bit of code here, right? So this can be really confusing to people. So a lot of times what I tell people is instead do on matchmaker matched like so, and then we can just create that function right here, and then basically paste this code, get rid of that await like this, or that async right there, and then we can just do matched instead dot match ID. I'm pretty sure that will be about the same. So matched dot match ID, and it's going to be mad at us because this is not asynchronous, so I'll make it asynchronous. So we'll say async like that. And once we have this set here, we should be good to set up our match. So now if we go into Godot here, we hit Control S, we go ahead and fire off our 2 clients here. We connect to Nakama. We'll come in here, submit, test 2, submit. We're going to click start matchmake, and we got an error, so that's not a good sign. Null reference exception. Object reference not set to an instance of an object. Looking at it, it looks like we don't have a socket just yet, which makes sense because we actually never built our socket. So let's scroll up here. You can see here's our socket creation. So we'll just copy this bit of code here, and we'll bring it down here. So that way we're actually creating that socket. Now let's go ahead and try that again. So we'll refresh. Let's try this one more time. So we'll submit, we'll start matchmake, we'll do 2, submit, start matchmake, and then you'll see after the configure timeout, which it's going to take a second. So we'll let that kind of chill for a minute. So you can see that they're communicating with Nakama right now, getting their matchmaking. If we take a look at our configuration and we go to match make, you can see this matchmake interval seconds. You can see it's set to 15. So that means that it's going to wait for 15 seconds before you get matched. So you'll see in a minute, hopefully, it will match up. Well, it's not actually going to tell us anything if we actually matchmaked. So let's actually do this. Let's go gd.print joined match with ID, and then we'll put in that ID. So I'll put in a $sign here. Bracket match. Let's see. If we go to join match async, that's going to return an iMatch. We actually would want to do this. Let's do match is equal to that join match with ID match.id. ID. Let's see if that worked better. Because I believe it should fire off. Yeah, because here's where it's joining match asynchronous, join match with match ID. So that makes sense. Yeah, we could try that. So let's try that and see if that's going to give us a better result. So we'll refresh this because before we weren't really showing any of that information off. So we'll submit, start matchmake, test 2, submit, start matchmake. Let's see if that fires us off real quick. All right, so I feel like our start matchmake is not actually working properly. Okay, so I figured it out. So basically, it was my fault all along, which it always is. But what it was I originally thought maybe we had to create the match, but we don't. So this has two different functions that I missed. So instead of doing matched ID, so match.id, right? Instead, just do matched, and then that will matrix it across and then automatically do the connection. The other big thing that I changed was here. So with one of the newer versions of Nakama, you need to come in and do properties.skill and then do this instead, and then properties.mode, right? So basically Nakama's code requires us to add the properties dot to it so that it knows it's a property of that match. So that's my fault, and I just couldn't believe I made that mistake, but there we go. So once we have this, we can go ahead and go into Godot here. We can hit play, and then you'll see I can go test. I can say start matchmake, test 2, submit, start matchmake, and then you'll see in a second that it's going to create those two tickets, and then they'll get connected together. It'll take about 15 seconds or so. And there we go. So you can see we have now connected, and now we can ping, and you'll see it's going to go across to the other person. And then if I grab the other one and I ping, there you go. You'll see that it goes out to the other person. And that's basically how we can do matchmaking inside of Nakama. Now the question is, once we have matchmaking, what else can we do, right? Well, Nakama has the capability for us to be able to store data out on their system. So you can see with the actual Nakama console here, you can see that we have this thing called storage. And basically, storage allows us to store data. So if we want to store data, all we need to do is we can go into Godot here, and we can basically create a panel for that. So we'll right click, add in a child node. We'll go ahead and add in a panel. Now we'll drag this panel down here like this, and we'll just throw it down here in the bottom corner. I'm going to call it storage, like so. I'm going to right click, add a child node. I'll add in a button, and then I will go ahead and make 3 buttons. I'm going to have one for storing data, one for getting data, and then one for listing that data. So we'll come over here, and we'll type store data. We'll put another one in, and we'll call it get data from store. And then we'll do one last one, which I'll need to move these guys down just a tiny bit, give me a little bit more space here. And we'll name this one list data from store, like that. And I'm going to grab this guy. I'm going to expand it so that way it just kind of matches, because I like my stuff to look somewhat aesthetically appealing. So there we go. Just kind of get these guys in the right spot. And what I'll do is I'll come in here and I'll type store data, get data, and then list data. And then I'm going to come in here, and on store data, I'm going to go in and I'm going to do on button down. I'm going to copy this guy, connect it. I'll scroll down here, and I will go ahead and do private void paste bracket bracket like that. We'll do the same thing for get data, button down, Control A, Control C, connect. We'll scroll back down to the bottom like we did before. Private void paste parentheses bracket bracket, and then we'll do list data as well. So we'll grab this guy, copy, connect, go down to the bottom, private void paste parentheses bracket bracket. Now, in order to store data, it's actually really simple. Nakama makes it really easy to work with. So if we want to store data, we need to create some kind of an object, okay? And basically we can then pass that data in and JSON write it out. So what we'll do is we'll come in here and we'll have to create an object to write that data. So let's come up here, add in a new class, and we'll go ahead and name it player info. And that's going to create a public class player info. And then what we'll do is we'll come in here, we'll just say public string name, we'll do a capital name, public int level, and then we'll say public int skill, let's say. Then we can come to our Nakama client. We can go ahead and create that object. So we can say player info is equal to a new player info. I'm going to hit bracket, and then I'm going to come in here and say name is equal to test, comma, skill is equal to 100. And then I think we had level. Level is equal to 10, like that. And then we need to basically pass this data in to our storage object. So we'll say write storage object is equal to a new write storage object, bracket, and we can come in here and basically define where we want this data to be stored. So first things first, there's what's called a collection and a key. So we'll type collection is equal to, and we'll put player info, let's say, comma, and then we can say key, and we can call this player 1 info, like that. And then for our value, what we can do is we can set that to some kind, our player info as JSON. So we're going to need to write this as JSON information. We can go JSON writer dot to JSON, and we can pass in our object. So player info, like that. And then we have two permissions that we can do. So we can have permission to read and permission to write. So if we go permission read is equal to 1, what that's going to do is it's going to tell it that only the server and owner can read it. Okay. And this is big. This is important for us to know. So we can do stuff with a 0 or a 1, and a 0 will allow anyone to read it. A 1 will let it only happen to the server and the owner. So typically you just want to have it so that the server and the owner can read it, and that's it, because that's going to make it a little bit more safer so that other people can't pull that information. So we'll do permission to write, and we'll make that equal to 1 as well. And now we can go ahead and send that out. So we can say await client dot write storage objects async. We can pass in our session, and then we can pass in our object. So this is going to be a list of objects. So I'm going to go new bracket, so it initializes it, and then I'll pass in our write storage object, like that. And that will go ahead and store that data up there. Now, if I hit Control S and I go to Godot real quick and I hit play, you'll see when I submit and then I hit store data, you'll see that we don't get anything, right? No confirmation, nothing. But if we head out to Nakama and we refresh our storage objects, you'll see that we have a collection name called player info with a key called player 1 info with a user ID and the last update. Now, the collection name does not need to be unique, and the key name does not need to be unique. However, the key name needs to be unique within the collection. So you cannot have two player 1 infos. You'd have to change the name if you wanted to store 2 copies of the information. Now, if we click on that, you can see here's the collection, here's the key, here's the permissions, here's the user information that's associated with it, and here's when it was created. And then you can see our data right here. And if we format it, you can actually read it in an easier way. That's what that little button down there is for. You can see that's the information right there, which is awesome, right? It allows us to actually store information. So now that we know that we can store the information, how in the world can we read that information? Well, in order to read that info, all we need to do is we can come back here to Nakama and we can go to our Get Data button down. And what we can do is we can basically a storage object. So var storage object is equal to a new storage object ID. We'll go bracket bracket. We'll type collection is equal to, and that's where our collection comes in. So player info. So player info, comma, and then we need to pass in our key. So our key is equal to player one info. Simple enough, right? So player one info, comma, and then we have to pass in our user ID. So user ID is equal to session.user ID. And then for us to be able to pull back our information, we need to say var result is equal to await client.read storage objects async session, comma, new bracket bracket curly braces storage object like that. And then we can just hit our semicolon like that. And then from there, we have our result. Now, our result will have a list of objects. So we need to actually pull that. So we can say if result.objects.any, like that. So if we got anything back, now we can return that information. Now, you'll see that objects is an API storage object. It's an IEnumerable, which means that it's a list of objects. So in our case, we're only expecting one return. So we'll say var object is, I guess we can't use object. obj is equal to result.objects.first, like that. And I'll just return our first one. And then I will say gd.print $ data received is, and I will put in bracket bracket JSON parser dot from JSON, and our type of object will be the object that we wrote, right? Our player info. So player info, like that. And then we can pass in our object. So storage object dot obj dot value, like that. And that'll return back our first element on that array and then print it out. So now we should be able to hit Control S, and this might not work. We might need to actually just print out the object value. So let me do bracket bracket like that, obj.value as well. So that way we're not parsing the JSON. That way we have this stuff as text and we have the actual object, because it might just display the object depending on how it feels. So now we can come in here, we can refresh, we can connect, and then get data from store. And you can see right here, yeah, see how it didn't actually display the information as expected. So you can see there is our data right there. We have our level, our name, and our skill. Easy enough. Now you might be asking, okay, so what happens if we pull two of these guys? So we have one and we have two, and we have test one and they're connected and they store data. What happens? Well, if we take a look at our Nakama and we go back to our storage, you can see that we have two of the exact same one, right? And the reason why is because it goes off of the user ID to define uniqueness. So think of it kind of like a tree structure. It goes user ID first, then a collection, then a key. Keys need to be unique, but keys do not need to be unique under different collections. And keys can also not be unique underneath collections if they're under a different user ID, if that makes sense. So think of them as just like different buckets of information, if that makes sense. So that's basically how that operates. Now, The last question is, how do we actually list data? Because sometimes you might want to pull back and list data instead, because sometimes you don't need to do multiple read requests. You might just want to pull back everything that is inside of that storage, right? Everything that's inside of that object. So if I come in here and I change this real quick, so that way we have some additional data. Let's do player 2 info. And then let me refresh this real quick. Let me log in as test. And then let me store data. So if we take a look at Nakama, you should see that there is now a player 2 info as well underneath the same user as ID as our first one, right? Well, if we want to get both of these guys, right? So key name 1 and key name 2, there are times in which we might want to pull both of those at the same time. And that's where listing storage kind of comes in. So how it works is basically you could do list user storage objects asynchronously, okay? And what we'll do is we'll come into our client here. We can come down here and basically just say var limit is equal to, let's go with 2. So that way if we have 3 of them, it doesn't come back with more than 2. Then we have to go and pull our data. So var player data list is equal to await client dot list users storage object asynchronously, like that. We could pass in a session, comma, and then this is what collection we want to read. In our case, we want to read our player info, right? Because we want to read that information. And now we have to pass in the user ID that's associated with it. So that's going to be our session.user ID, comma, we can pass in our limit. And then if we want to pass in a cursor, we can. We probably don't need to. So I'll actually just leave that as null by default. And a cursor just says, where are we starting in our stack? So I wouldn't worry about that because typically you're probably not going to use it that much. Now, this also works, by the way, if you guys want to pull back a user's information that is public. So if your information was public and other people could read it, you could actually use this to read that. You could pass in the session.user ID right here. You could actually just pass in the other person's user ID and pull back that data, if that makes sense. Now, we have to actually display that info. So for each var data in player data list dot objects, and then we can basically just parse that data and print it out. So I'm going to say gd.print data is bracket, and we'll go ahead and put a $sign at the beginning of this, data dot value. And this is where you would parse that data and actually parse it into objects for your project. Now we can come in here, go in here, hit refresh, and then hit submit list data. And you can see that we have 2 of those data. Data is level 10, test skill. Now, if we go out to our thing here, we click on our key. Let's go in here and change this data. Let's say Bob and skill level of 150, and let's save that data. And then let's come in here and let's grab, which one was it? This one or this one? This one. Let's list that data again. You can see that we get our test and our Bob. And that's the reason why I switched the information, is so that way we could see what it looks like. But you can see we pulled back this one and we pulled back this one and displayed both of them. And that's the power of the Nakama storage system. So now, how do we actually create friends, right? So one of the really big features inside of Nakama is to be able to create and add friends. So what do we do to actually approach that? Well, it's actually relatively simple. All we need to do is we need to come in here, create a panel. And I know that a lot of these are panels, which means that, people aren't just going to add friends this way, but I'm showing you guys how to approach it so that you guys have that capability, if that makes sense. That way you guys can hook up the different signals and different functions for your own use. So what we're going to do inside of here is we're going to call this friends, like that. We're going to right click, add a child node. We'll add in a button. we'll go ahead and make this button about this big. I'm going to duplicate this button, bring it over here, duplicate it, put it right here, duplicate it, put it right here, and then we're going to right click, add a child node. We'll add in a line edit like so, and then we'll put it like this, make it nice and large. And then I'm going to put in a placeholder text, name of friend, like that. That's going to give us some way to be able to communicate, choose what friend we want to add. Now I'm going to come in here and I'm going to put friend text, or I guess friend name probably would be a better title for that. So we'll do friend name. And then I'm going to come in here and name these guys. So we'll name this get friends. We'll come in here and do add friend. This one will be block friend, because sometimes you want to block people, and delete friend, because sometimes you just aren't friends with people anymore. So we'll put delete friend, block friend, add friend, and get friend. There we go. And once all that's hooked up, we could just come in here, go like this, Control A, copy, paste, and scroll down here, which it's not in the right direction. There we go. We'll say private, void, paste, parentheses, bracket, bracket, add friend, button down, Control A, Control C, connect, scroll down, paste, do that, block friend, button down, Control A, Control C, connect, scroll down. There we go. And then delete friend. We'll do the same thing. Hook it up, go down, private, void, paste, parentheses, bracket, bracket. Now, once we have this, we can go ahead and just add our friends. Now, the fun part is we can do one of two ways to add a friend. So if you look at add friend right here, we can add a friend via their user ID, or we can add them via their actual username. So if you type await client dot add friend async, you'll see here you have different options here. So we'll pass in a session, comma, and then you can see we have a IEnumerable string. And what this does is it allows us to add multiple friends if we want to, or we can do an IEnumerable's ID, right? Username, right? So that can allow us to have whichever one we would like. Now, in my case, I'm going to do null, comma, new, parentheses, bracket, space, and then I'll pass in the username that the user puts in, because typically people don't know what user ID they're looking for. Like if we look at the console and we go to user management or accounts, I'm sorry, they would have to input this unique identifier, and that's just not going to happen. People are not usually knowledgeable enough to know that GUID, right? They're not going to remember somebody's GUID and put that in. So we'll go with the username. So test2, test1, or test. So if we head back to here, we can just pass in the path to this line edit right here. So we'll pass in get node, line edit, friends slash friend name dot text, like that. And that'll allow us to add friends. And that should be pretty much all we need to do. So if we head over here, we hit play. If we log in as test, so we're just logged in, test1, add friend, you should see, if we take a look at our Nakama console, if I go to test friends, you'll see that he has a friend of test1. So test1 is now a invited friend, right? So you can see it says invite sent. So the only way that this works where both people are friends is if both people add each other. So let's head over here, say test1, let's log in, and let's go test, add friend. And now if we refresh, you'll see that they are now friends. So the way it works is I have to request your friendship, and then you have to request my friendship. And then once we both request friendships, we are now friends. So that's how you handle that. Now, how do we actually list what friends we have? So if we head back here, we have a get friend, right? So we need to be able to list those friends. So if we head over to our code here, you have on get friend right here, we can actually list our friends by doing something like this. Var result is equal to await client dot list friends async, like that. And then all we have to do is pass in our session, comma, and then we have what's called a state. Now, a friendship state is if you're friends, if you have them outgoing, incoming, or blocked. So you can actually limit them by that. So if you want to, you could say 0, and it will only display people that are currently your friends. If you look at your Nakama console, you can see friend 0, right? So if you were to request a friendship of, let's say, test 2, and you had a requested one, and then you set 0 here, then you're only going to get back test 1 because it's the only one that's actually accepted your friendship. So it's a good way to delineate which ones you guys are trying to pull back. So that way you're not pulling back a bunch of people that you don't need. The next one is the limit. So how many people do you want to pull back at once? So let's say something like 10, right? So if I have 100 friends, I will only receive 10 of them. And then they have a cursor, and I'm just going to pass that as null. And then I'm going to loop through for each var item in result dot friends, like that. And then I'll just log out that data. So gd dot print item dot, and you can see all the different data that you can print out. So I'll just do it to JSON. So that way it's just converted to JSON. And now if we head back to Godot, we refresh, I log in as test, and I say get friends, you'll see that I get back the one friend that I have, which is right here, test display name, right there. So this is the guy that I added as my friend, test1, right? There's test1. If I come in here and I say test2, add friend, get friend, you'll notice that I only have the one friend. Even though inside of Nakama, and I refresh this, you'll see test2 invite sent. That's because of that delineation that we did earlier. Remember, we said right here that we were going to do 0. So anyone that's state 0 is our friend. See, this guy is state 1, this guy is state 0. So therefore, when we do our search, we only get the one that we're looking for. Now, if we head back into here and we log in as test2 and we add test as a friend, and we come into our Nakama console, now we're friends with that person, right? So I'm logged in as both the guys, right? So I have test and test 2 right here. If I get my friends now, you'll notice that I have both of them in my data. I have right here test 1, and then I have test 2 right here, and that's it. So that's basically how you can get your friends inside of Nakama. And if you want to make this a little bit cleaner, you could just do item dot, I think if I look at friends, it's an IAPI friend. So it'd be user dot display name. That will give us a little bit better data to work with just because it looks better. That being said, we don't need to do that. I'm just doing it for, looks. There we go. So you can see test display name, test display name. Technically, we should probably pull back the username instead because it's going to show test display name for both of them. Let's do username instead and then refresh this. I just want to show you guys how this works so that way you guys can see that it actually does work. So if I get friend, test 1 and test 2. So that's basically how that works. Now the question is, how do we block somebody, right? Because sometimes you need to block a person, right? This person's really annoying. They're causing a lot of problems. Test 2 is kind of a mean person. I don't want to talk to that person anymore. I don't want to deal with that person. So how do I block that person? Well, blocking is actually really, really easy. All you do is say await client dot block friend async. We pass in our session, comma, you can pass in an ID, much like we did when we added a friend. In our case, I'll just null that out because I don't really want to use the ID. And I'll just basically copy this bit right here. That's going to get me what I need. So we'll just paste that bad boy in there. That's going to hook up our stuff the way that we have it hooked up here, right? So we're passing in our friend name text. And then I'm going to semicolon that bad boy. Now, once we do this, all we have to do is refresh. And I'm going to block test2 because he's a mean dude. So we'll submit test2. Let's get our friend. You'll see we are friends with test2. If I block friend, I clear this. So that way my console's clear. I get my friend. I am only friend with test1 now. If I refresh, you'll see that that person is blocked. And if I remember correctly, it should also stop them from matchmaking with you as well. So that's one of the nice features here that blocking achieves. Now the question is, okay, test1 and me, we had a fallout. We're not friends anymore. He said mean stuff about my mom. What do I do? How do I actually delete him as a friend? Well, that's really easy. All you have to do is type await client dot delete friends async, and it's exactly the same as we did before. So you pass it a session, you pass in the IDs if you want to block an ID, and you pass in the username if you want to use a username. And that's it. So then we come over here, we can refresh. I could say test, get friends. I'm friends with test1, delete that friend. I don't want him to be my friend anymore. If we refresh our console, he's now removed from our stack. And if I clear this and I get friend, you'll see that we're getting no data. That's because we're not friends with anybody anymore. We removed all of our friends. We blocked them. We don't have any friends anymore. And that's basically how the friends system works inside of Nakama.
Now we have a very basic understanding of what Nakama is. Let's go ahead and kind of put this into action. So one of the most important parts of Nakama is actually being able to do multiplayer, right? Being able to have your characters move around and things like that. So how do we take this theory and kind of move it into more practice? Well, the simplest way is by building out a small basic game. Now, I'm not going to go through and actually fully construct a game and have the entire thing built out. I'm going to make a very simple, your character can move left and right, and the other character can move left and right, at least for this tutorial, because it's something that is going to take at least an hour to just build out. So I feel it's going to be easier just to build something simple and then go from there. So first things first, let's go ahead and build a character controller, right? Because we have our stuff, we need some kind of, way to move a character before we can even get started. So let's go into scene, new scene. Let's go ahead and add in a new 2D scene. And let's go ahead and right click, change type, and let's go ahead and make it into a character body 2D. Let's right click, add in a child node. Let's add in a sprite. Let's go ahead and right click again, add in a collision shape 2D. We'll go ahead and grab our sprite 2D, go to inspector, drag our icon in, scroll in like this. Let's grab a collision shape and make it rectangular. We're going to go ahead and make this about yay big, give or take, like that. Now, with this player, we're going to name this as player right here, like that. We're going to go ahead and right click our player, attach a script, and we'll go ahead and attach a character controller.cs script to it. And you'll notice a lot of it has already been coded for us, which is great. So we don't really need to do a whole lot here for our project to be successful. But what we are going to need to do is we're going to need to be able to synchronize data through this. Now, it's going to be a little strange to synchronize our data, but what I'm going to do, and this is going to bounce around quite a bit, so forgive me, but what I'm going to do is I'm going to go to my Nakama client, and I'm going to set up a very basic synchronization system. So what we'll do is we'll scroll up to the top. We're going to make a signal, okay? And how this is going to operate is we're basically going to have signals that broadcast out the data depending on the type. This is going to make it a lot more flexible for us in the future if we want to expand this system. So we'll type signal, we'll do public, delegate, void, player, data, sync, event, handler, and we'll pass in a string data like that. And then I'm going to actually duplicate this a few times. So I'm going to copy this, paste, and I think I'll paste it one more time. And I'm going to need the other signal, which is right here. So we'll hit enter and enter like that. That way we have our stuff nice and set up. And then here, instead of player sync data sync event handler, we'll say join game event handler. We'll come in here and instead of data sync, we'll say game event, or I should say start game event handler, and then we'll come in here and do ready game event handler. And that'll give us the 3 separate ways that, or I guess the 4 separate ways that we really need to interact with our game, at least as of right now. Something else that we're going to need is we're going to need some kind of player info object that we can use. And we kind of built one right here, which has name, level, and skill. And that's totally good, but I think we're going to need a little bit more data than that. I think we'll also need public string ID, and I think that will work. Maybe status as well, so public int status. Now, you might be wondering, okay, what are these even for? And I'm defaulting that to 0. I think by default, int is 0 anyway, but we'll just default it because it makes me feel warm and fuzzy on the inside. So what are these 2 for? So this is going to be the player's unique ID, and then this will be if the player is ready or not, or any other status. And basically the idea behind this right now is just if the player is ready or not, 0 or 1. But in the future, we might want additional statuses for our player. What if they're disconnected? What if they've had an issue where they are cheating or something like that? We could always create different statuses for that player, if that makes sense. So I just kind of want to put that in there. Now, if we head back here, we're going to need to do a few things. So first things first, I am going to do a dictionary for my players. So I'm going to say public static dictionary bracket string comma player info, like that. We'll hit players. We'll make that equal to a new object. Now, this is going to house all the players in the game, basically. So anybody that's going to be playing a game with me, that's going to be these guys. And we want that to be available to us. Now, don't worry, we haven't forgotten about these guys because these guys are going to be our events. And this is going to be big for us. So if you remember, when we have our on match state, which is right here, we printed out that data, right? We just received data from user and just printed out that data. Well, now we need to basically check what the data type is and then broadcast that data out. So what I'm going to do is I'm going to go switch on state.ops code, like that, ops code or op code. And then I will hit parentheses, case 0 is going to be doing something, right? So break. Case 1 will be doing something else and then break. Case 2 will be doing something else, break. And then case 3 will be doing something else and then we're going to break. Now, I know what you're thinking. Okay, go on, right? What do these things mean? Well, basically, what these guys are for is these ops codes. If you remember, we talked about it before. When we send data, we send an ops code. So I believe we have one where we send some data. I believe it's ping. Let me find it real quick. When we ping, we send a message state async match ID 1 data, right? Well, that's basically what that ops code is. It's the 1. So when we receive that data on our match state, it's going to come through here. We're going to check, and then we're going to say, oh, it's a 1, so therefore it needs to go here to be processed, if that makes sense. Now, what I'm going to do is I'm going to tell it to broadcast a signal with that data. So for instance, a 0 is going to be a join game. If somebody joins a game, I'm going to use 0 as that. And it doesn't have to be the same for you, by the way. You could have it as a 1, you could have it as a 2, a 3. It doesn't really matter. You guys can make it whatever you'd like. But in my case, I'm going to go ahead and emit a signal. Now, inside of Godot, it gets really, really mad at you if you call a signal from an asynchronous function. And unfortunately, this is going to be an asynchronous function, so we're going to have to call defer it. So we'll call deferred, and then I'm going to go name of and then I'm going to pass in a function I want to call. In my case, I'm going to call it emit join player join game signal, comma, and then I'm going to pass in my data like that. Now I don't have a function called that, so I'm going to come down here and say public void emit player join signal, and I'm going to pass in a string data like that. And this is basically going to call this deferred, right? So it's going to call it at the end of the cycle once everything's kind of settled. Then it will call that function and then run it. And it's introduces a little bit of latency, but it makes it so that everything's a little bit safer for us to work with. So I want to do it that way just in case. Now, when we emit our signal, all we're going to do is type emit signal name dot, and then we will call it player joined game, comma, data, like that. Very simple. So it's a very simple little function here. Now, you could just do something simpler like this if you really wanted to, equal to pointer, and do this. And that's also valid. So don't be afraid to kind of play around with it and pick whichever one you want to do. Now, we have 3 others to do, so let's do that. And instead of emit player joined, we'll say emit player sync data. So sync data, emit player start, I guess it would be emit start game, and then ready game, like that. And then we're going to emit our signals as player data sync, player start, or I guess it's just start game, and then finally ready game as well. And I spelt sync wrong right there, so let's fix that real quick. And that's basically how we're going to emit our signals. And now we just have to copy this guy and paste and paste and paste. Now pass these guys up like so. And we can also do the same for our breaks if we want to as well, just to keep everything nice and formatted. If you want to hit Control-Shift-P, you can also format your document, and that'll help format this to make it a little bit more reasonable. Now, what this is going to do, well, right now it's just going to emit our player join signal. So I'm going to pass in sync data, game, and ready. There we go. So this is going to be like our central hub almost. So when stuff gets synchronized, we will be using this as our way to denote what information is going to get sent out. So think of it kind of like the decision man. It's the guy that's in charge of saying, this is where the data goes, and this is who needs to read that data, if that makes sense. So it's really useful for your game to have a central hub. Unfortunately, with GD script, or I guess fortunately with GD script, a lot of that's handled for you and abstracted away, so you don't have to see it. But inside of C#, they give you the keys to the kingdom, which can be a blessing and a curse. So just make sure you build this in a very good and scalable way, kind of like the way I'm going about it. And now we need to provide some way to synchronize that data. So you can see here we have our ping, right? Which is basically what we're going to do, but I'm going to grab this guy. I'm going to copy it, go down to the bottom, and I'm going to come in here and say public static void sync data, like that. And I'm going to pass in I think we'll go with a string of data and an int opcode. That way we can actually go ahead and synchronize our data. Now I'm just going to go ahead and paste that. And then we can just pass in data and OP code right here, like that. And for our data, we can basically just get rid of that and do that. And I think that should work. Let's see why it's mad at us. A wait operator can only be used with an asynchronous method. That's because this needs to be public static async void, and then socket object reference not set. That's because it's static. So we might need to make our client and everything static, which is fine because we're not going to expect to get multiple clients or anything like that. So I'm going to make these guys static, which tip, if you hit Alt Shift click like that, you can type multi-row, and that is a huge useful tool when you're working with these kinds of things. Something else that we should probably do is make a static controller as well. So I'm going to do that. So public static Nakama client, and then I'll just come down here and basically say if client does not equal null, then set client equal to this, else we'll queue free. Like that. And that'll basically just rip this out so that way we don't have to deal with that. The idea behind this is that if we ever need access to whatever our current client is non-statically, we can do that. So for instance, if we needed to, run on match state or something like that, we can do that right here. Odds are we're not going to need it, but I'll add it just in case so that way it exists. Now, this right here means that we can actually use this, and I'm going to go with a pointer like that. There we go. That just gives us a little bit cleaner code, and really we should do pointers for all of this, but now I'm just being a bit ridiculous. But I don't really want to, so we'll just leave it like that for now. But basically, we could just fire this off, and as long as we pass the proper ops code, we should be good to go. So the reason why this is important is because we will have a centralized location to synchronize our data. And that means that we can basically use this to synchronize all of our data. So if we go out to our character controller, we can synchronize whatever data we need to synchronize. So what that means is we can go into our character controller here and actually synchronize our data whenever we want to. Now, we're going to need to do a little bit of checking if we're a local player. So basically, if I explain it, to explain it, if I open up Draw.io real quick, which you'll see my little Docker thing here. When we want to synchronize our data, we don't want, let's say we have two players here like this, right? When we hit left, we don't want both of our players to move like this, right? If we hit left and right, we only want one of our players to move if we move it, and then we want it to synchronize on the other player. So if I, create a second one here, let's say, when we move this one, we want to move this one. And when we move this one on this side, we want to move this one, right? So we can't just say, hey, move one of these players. We need to check to see if we are the proper player. So what we'll do is we'll label each player with their ID. So something like test1 and test, and then test1 and test, right? And then we'll basically have some code that's going to check if name is equal to the data.name, right? So we're basically going to tag all of our data with movement data with our name, so that way we know who is moving who and when they're being moved. That's kind of how we're going to approach that, if that makes sense. And it will probably make more sense as I go through it, but I just want to kind of explain it so that way you guys can sort of understand. What I'm going to do is come up here and I'll say public player info like that. And I got to capitalize that I because it is a public object. And what I'm going to do is say, if my name is equal to my info.name, or I guess in this case, ID, because we want to go by ID, not name, then we're going to allow you to move your player like that. And then we need to synchronize that data. So after we've moved everything, we need to synchronize the data that's going across. So how we can do that is by creating a function. So we'll say sync data like that. Then we'll come in here and we'll say private void sync data. And all this is going to do is it's going to handle any of our data synchronization. And it's not happy. My guess is because this needs to be moved here. Go. No, I was right the first time. I don't know why it's mad at me. Sync data. Data does not exist. Oh, that's because I misspelled sync. That makes sense. So we'll put sync data. And then when we want to sync our data, it's going to be really, really easy to do. All we need to do is grab our Nakama client, like so, dot sync data. And then you can see we have a string of data and an ops code. So simple enough, right? What are we going to try to synchronize? And that's a actually legitimate question. What do we want to synchronize for our data, right? Well, we need to synchronize our player data. So let's create a class to handle that. So we'll come in here and type class, and we'll add in a class. We'll call it player sync data. And that's going to create a class right here. Now, what are we going to synchronize? Well, in this case, it's basically just position information and then maybe rotation information if we want to. So what I'll do is I'll just say public vector2 position, public int rotation degrees, like that. And then I'll come in here and I'll basically create that object. So I'll say player sync data is equal to a new player sync data. We'll do parentheses and then bracket, and then we'll say position is equal to global position, like that. Rotation degrees is equal to rotation degrees, like that. You'll see it's a little mad at us, so it cannot implicitly convert a Godot vector to systems numerics vector 2. That's because if we look at our stuff here, you can see we have the wrong using statement. So we'll say Godot, like that, and that should work. And we also want to pass it an ID. So public string ID, like that. Now this ID is going to delineate what player is sending the data. And we also have a cannot convert float to int, so we'll change this to float. And then we'll pass in our ID as our name, like that. And there we go. And now when we want to synchronize our data, we need to pass in our data as a string, which in order for us to actually convert the data, I'm going to use Newtonsoft because I like Newtonsoft better. So I'm going to add that as a package. So we'll go to new terminal. We'll type .net, add package, Newtonsoft.json. That's going to add in the Newtonsoft.json. Technically, you could use the Godot JSON, but I prefer how Newtonsoft operates, so I'm going to use that. And I'll say JSON convert, and we'll pass in dot serialize object, and then I'm going to pass in the player sync data, comma, and then we can choose what our ops code is. So if we take a look at our Nakama client, we have it set to, let's take a look, player sync data 1. So we'll pass in a 1 like that. And I know that I'm kind of going everywhere, right? So it's going to be a bit confusing, but the reason why is because everything's kind of jumbled. Everything kind of works together. So you have to get it all in line and then it all works suddenly at once, if that makes sense. So it's kind of a bit on the confusing side, but I promise I will walk through and explain why. Now we need to receive that synchronized data. So we're sending the data out to be synchronized to our system. Now we need to parse the data that comes back, right? So in order to get the data, we need to subscribe to the signal. So we'll say public override void underscore ready, like that. And we'll do a base ready. And then we'll come in here and we'll subscribe to that data. So we'll type Nakama client dot, and then we can grab our signal that we're trying to subscribe to. Sync, I believe it was player data sync event handler, but you can see that it comes back as player data sync event handler. That is where our dot controller, or our, I believe it was client dot sync data, emit player sync data, I believe we called it player data sync. So we'll say player data sync, like that, plus equals on lowercase n player data sync, like that. And then we will click on this guy, hover over it, quick fix, generate method, and that's going to generate a method for us. And now we know that we're getting back the data that we expect, right? Because this is a round trip, right? So all we need to do is deserialize that data and then process it accordingly. So all we need to do is we need to come in here and say var data, or I guess player data, is equal to JSON convert.deserialize object as a type player sync data, like that. And then we'll pass in our data. And that's going to deserialize that data. And then all we have to do is check if our parsed data or our player data .id is equal to our name, then we know it's ours. So now we can pass in our data. So global position is equal to player data dot position. Rotation degrees, even though it's probably not going to change, we'll use that as a capability, is equal to player data dot rotation degrees. And that's basically all we really need to send over. I believe we also sent over, that's it. So we just sent over that data. So that is how we're going to synchronize our data set. So now, since we have this synchronizing, right, all we need to do now is handle our players joining and leaving games and spawning our players. So this should handle our data getting synchronized, right? So this is actually delineating between our players, determining that they're the correct player, and we're processing the data and putting it into the proper spots. That's basically how this is operating. Now, next, we need to actually handle spawning our players and handle our player management and lobby management. So now let's set up our player management section so we can spawn our players in. We'll go back to our Nakama client, and we're basically going to handle our player housing here, if that makes sense. So what we need to do is we need to come in and let's see. When we join a game, we're going to need to grab our presence, if that makes sense. So we're going to synchronize our presence here. So when we do our join button, which I'll be doing the match ID instead of the other one, but this code basically just goes over there as well. So you could just duplicate it if you want. So for each var item in match.presence, if not players.contains key item.username, then we'll go ahead and add that in. So basically what we're going to do is when we go and connect to our match here, when we connect to it, we're going to get back a list of players in the match. So I'm going to just kind of house that information right here. So we'll say var item in match.presences. So those people that are actually in the match. If player contains key item username, then if it doesn't, then what we'll say is players.add item.username, comma, new player info, and then I'll just pass in, for now, if you guys want to hook whatever you want, you guys can, but ID is equal to item.username, like that. And I'm going to use username just because that's going to be easier for us to understand than some random GUID, right? And then what I'm also going to do is I'm going to call deferred, so call deferred, and I will call name of emit player join signal, and I'm going to pass out that item.username, like that. And that's so that if we have any UI elements or anything that wants to show that the player's joined, we can go ahead and do that here. So that's kind of what that's for. And then what we'll also do is we'll say if match.presences.count is equal to 0, then we know that we're the host. So we'll just say, we will go ahead and create a Boolean to handle if we're host. So I'm going to say is host is equal to true. We'll come up here and we'll add that as a Boolean. So we'll say public static bool is host, like that. All right, so that's what happens when we connect, right? When we connect, we want to get back all of the people that are currently in the actual match, right? So this will get all the people that connected before us. But what happens if people connect after us? Well, that's when we get a match presence, right? So if you remember, we had a on match presence right here, which was when we printed out that event, right? Well, that gets fired off when people join, right? So we can just say for each var item in at event dot joins, like that. That's when people join. And actually, if you take a look at that event, you can have join and leaves. So you can actually handle both. In this case, I'm only going to handle joins, not leaves. But if you want to handle leaves, you could basically just say for item in event dot leaves and then remove those players from your list as well. So same exact code as before. If we scroll up, we'll basically just grab this code, copy, and paste that in. And if we want to, we can also say for each var item in at event dot leaves, like that, we could basically say paste if players dot contain key, blah, blah, blah. Then we can come in here and say player dot remove. And we'll need to pass in a string key, so item dot username, and that's going to remove them from our players. And then instead of emitting player join game, we'll say player leave game signal. Now we don't actually have that signal, so I'll come up here and I'll basically just grab this, copy, paste, and then join instead of join, we'll say leave game event handler, like that. That way we can handle both. We can handle when they join and when they leave. So it's going to fire off that event when that person leaves. Now we're going to need to create a function as well. So we'll copy this, paste it, and then we'll say emit player leave signal. And then we'll say player leave game, like that. And there we go. And that's how you can kind of extend our system, right? So it makes it a lot better and easier to work with, if that makes sense. So now we have when a player joins and when a player leaves and when a player creates a match, and it hooks it all up. So now our list of players right here is all basically set up. So now we need to actually spawn our players whenever they're ready, right? So if we head over to Nakama, that's not Nakama. If we head over to Godot, what we can do is we can hit Control S, save that as player. We're going to hit scene, new scene. We're going to create a 2D scene, and then we're going to right click, attach a script, and we're going to call it scene manager.cs. And we'll name this scene manager. And we're going to need to build out our environment. So we're going to right click our scene manager, add in a child node. Let's add in a tile map. And we'll go ahead and add in a tile set. Now, I already have a tile set right here. This comes courtesy of, if I go and find it, the pixel art platformer props. So you can go ahead and download these for free. They're completely free. So go ahead and download them and use them and give this man money if you can. It's created by a person named Kanos, and I really appreciate their work. And it's a really good set. So it's just good for us to have. So go download this, links in the description, and you guys can go ahead and use it for your project. Now, when we want to build out our tile set, we'll click on this and we'll set this to 32 by 32. And then we'll go to tile set, new. We'll come in here, we'll drag in our tile set ground, hit yes. It's going to automatically create atlases for us. So it's going to build it for us. And then I'm going to come in here under paint, select a property, and I am going to put in physics, right? You can see we don't have a physics layer. So we go to physics layer, add element, and now we have a physics layer. So now we can click on this, physics layer 0, and I basically can just drag and make stuff collidable. I'm going to make all of this collidable like this. I'm going to make all of this collidable like that, this, that, that. Go ahead and drag all of this, needs to be collidable. And really, we don't need to make all of it collidable because we're not going to use most of this, but it's just good practice to just kind of come in and make everything work. Now, one thing that people don't know about the Godot system, at least people don't really talk about it too much, is when you do this, you can actually come in and adjust how this is actually set up here. So once I get these guys in and I have it all basically done, if I want this collision to be a bit more accurate, I can come in here and adjust this collision. And then that's going to be the way that this collision gets painted when I click. So if I click this one, you can see how it gets that collision as well. So that's how we can make it a lot better
and more accurate for our game. So that's just something to keep in mind. It's super useful when you want to go in and make your stuff a little bit better. So you can see like right here how this one could go, and if we drag this guy up here, pull this guy here, and then there, we can click, and then that's a little bit more accurate than what this looks like. So it's just something to keep in mind. It's really useful and nice to have. Now, once we have our tile set done, let's go in here to our tile map, and then let's basically select this, and let's just create 1 and 2, and then let's grab this and do 1 and 2 and 3 and 4. And there we go. And we have ourselves a very basic, tile set for our project here. Now, all it's going to be is it's going to be a player on one side, a player on the other, and they're able to move left and right. So it's going to be a very simple system. So basically what we're going to do is we're going to loop through our players and then spawn them in accordance to whatever their order ID is. So in order to do that, we need to tell our system where we're going to spawn that stuff. So what I'm going to do is right click, add a child node. I'm going to add in a node 2D like so. I'm going to drag this guy like this. This will be spawn point 1. This will be spawn point 2. I'm going to name this spawn 1 and spawn 2. And I'm going to click this guy, go to node, groups, and I'm going to call it spawn point. I'm going to copy that, hit enter, click this guy, spawn point. There we go. And that's going to give us a way to easily grab our spawn points when we want to spawn our players. So that's more or less what it's for. Now, if we go to our scene manager here, let's open that bad boy up. You can see we have our scene manager. Now we're going to need two things. We're going to need one way to spawn our player, and we're going to need to know what our spawn points are. So we'll export out our packed scene for our player like that. And then we'll go ahead and do a array of nodes, which will be our spawn points. And I'm going to make that actually private. There's really no reason to make this public because no one's going to need it, so we'll make it private. You should always make stuff private. If you can avoid making it public, you should. So let's see. Non-generic array can be used with type arguments. Does it need to be public? Let me see. Public. No. Using Godot collections. That makes sense. So private array node. There we go. And then on ready. So once the level gets spawned, we're going to go ahead and actually spawn our players. Now the fun part is we're going to go ahead and just grab where our spawn points are. We're going to loop through and then we're going to spawn our players. So spawn points is equal to get tree dot get nodes in group, and we'll paste our spawn point group, which I actually spelled wrong. It's SPAWN point. So let me change that real quick. That's going to bother me. SPAWN point like that. There we go. Copy. Let's trash that one. Make sure we have it copied. Paste spawn point. Make sure that this is the same. It is. Okay. So then we need to keep track of what index we're at. So int index is equal to 0. And then we need to loop through our players and basically spawn our player and move them to that proper index. So we'll say for each var item. So we'll say key in lowercase k, because there's no point in doing an uppercase K, in our dictionary, right? So we'll say Nakama client dot players dot keys, right? But I want to actually order it by our key, if that makes sense. So what I'm going to do is I'm going to do dot order by k equals pointer k, or key is equal to pointer key. So what this is going to do is, let's say I host the game, my ID is 1. Somebody joins my game, their ID is 2, right? If for some reason when I join and my ID is 2, if for some reason it comes in as 2 and then 1, when we spawn our player, that means our players are going to be offset.
we're going to have them in two completely different locations, right? So that's what this is aiming to avoid. This right here is just going to make sure our dictionaries on both sides on all of our clients are basically the same. Because if they're off, even by a little bit, it's going to break everything. So we need to make sure everything is equal and consistent. That's what this is for. So now we need to spawn our player. So var player is equal to player scene dot instantiate like this as a character controller, like so. And then we can set our player dot name is equal to our Nakama client dot players bracket key dot ID, like that. And then we can say if spawn points bracket index is a node 2D spawn point, then player dot global position is equal to spawn point dot global position. And then we can add that to our child. So add child player, and then we'll index, and then we'll increment our index like that. So what in the world are we doing here, right? Well, what we're doing is we're setting our player, right, and instantiating it. Simple enough. Then we're setting our name as our player ID. And this is huge because that allows us to control who is in control. If you remember before, we said that the usernames need to be correct, because if they're not, then things get broken really fast. So this is going to allow us to delineate all that information and make sure that everyone's consistent. And then we are spawning our then we're checking if our index is a node 2D. And the reason why is because we need to cast it as a node 2D for us to be able to get its global position. Because by default, array requires it to be a node. So I basically did that so that way we can cast it. It also allows us to have a little bit more flexibility because get nodes in group requires it to be an array node. So we need to cast it as a node 2D. So that's what this is doing. And then we're setting our player's position equal to the spawn point. So we're putting them in the right spot so that way they can spawn. And then we're adding that as a child of our scene. So that way the players can play in it. And then we're incrementing our index. So that way we move to the next spawn point instead of spawning our player on the same spawn point. It's going to move them to the other spawn point. So now we should be good to actually set up the last little bit here. So if we go to our Nakama client here, we need a way to ready up and actually get our game going. So what we'll do is we'll come in here, we'll Control S, call this test scene, and we actually already have a test scene. I don't want to overwrite it, so we'll call it test level, I guess, and we'll go from there. We'll click on test scene, we'll come over here, we'll go into our matchmaking, we'll add in a child node, we're going to add in a button like so. We'll make it about yay big, and then we'll go ahead and call this ready /start. I'm going to name this ready start, and then we'll go to our node signals, and we're going to go ahead and do a button down on that. We'll connect that, and then we'll scroll down to the bottom, and I'll say public void on ready start button down. And basically how this is going to work is we're going to ready ourselves up. So we'll say Nakama players bracket session dot username, because that's our username, dot status is equal to 1. So we're going to set our status to 1. So we're saying we're good to go. And then we'll go ahead and sync data session dot username comma sync, and we'll need to pass in our opcode for ready. So if we scroll up, opcode for ready is going to be 3. So we'll pass in 3 and we'll do that. And then we should be good for our ready section. Now we're going to need to
set up our ready code. So if we head up here, so basically, let me take a step back real quick. So basically, all this is doing is just saying, hey, I'm ready and I'm good to go. And then it's going to say, hey, go synchronize that and tell everybody else that I'm ready. More or less. That's all it's doing. And then we'll scroll up to our ops code section. So right here, we're calling deferred emit start game, emit ready game signal. So here, we're going to be emitting our ready game signal. And then we need to actually come in and set our statuses up. So we'll say players bracket data dot status is equal to 1. So that's going to set the player status equal to 1 if they are on the other side. So think of it kind of like two sides of the coin. The previous one was them broadcasting out to people. This is where we're receiving that data. So we're saying, yes, we understand that we are now ready, right? And then we're going to say if is host. So if we are host, then we can go ahead and check to see if everyone's ready. So if players.any x equal to pointer x.value.status is equal to 0, then we'll go ahead and return. So we're not going to do anything. However, if everybody is ready, then we're good to go. So we'll say gd.print host start game, like that. And then we'll fire off a start game. So we'll say sync data, no data, comma, and then we're going to go ahead and do, it looks like start data is a 2. So we'll do a 2. And then we'll call deferred name of our actual start game signal, like that, comma, data, like that. And then we'll say gd.print ready to start, like that. Now we might not, actually, I don't think we really need that. We can get rid of that. So what this is going to do is it's going to call deferred emit game start. So that way we can actually catch that signal and use it elsewhere. So again, it's all a game of trying to make sure that everyone stays synchronized, if that makes sense. So the idea is that since we're calling this out, our start game signal, this is going to tell our host to start the game. And then when we do this sync data with a 2, it's going to come up here and call deferred our emit start game signal. And that's going to tell everyone else who is not the host to start the game, if that makes sense. That's basically the delineation there. That's how that works. Now, once we have that, we can basically start our game. Simple enough, right? So how do we actually start our game? Well, all we really need to do is we need to load our player scene and then instantiate our players. Now, typically, this would be handled kind of elsewhere, most likely in like a game manager. So what we'll do is we'll go ahead and build out a game manager. So we'll come in here, we'll go scene, new scene, 2D scene. We'll call this game manager, like that. I'm going to right click, add a child node. I'm going to add in a control node. And this control node will basically be where our UI is going to be located. So we'll type UI. And then I'm going to right click, add in another child node. And we're going to add in a node 2D. That's going to be where our world is located. Now, if you wanted to abstract your Nakama multiplayer controller, you could create a node here and just kind of abstract it out and just have it exist on its own. It's up to you. In my case, since it's part of the UI, I'm just going to keep it there. So that way it just exists there. But what we can do is we can come into our test scene. We can drag that bad boy in. And there we go. So now, once we want to just get rid of that, we can hide it or queue free and just kind of delete it. It's up to us on how we want to handle it. That being said, with this being the Nakama client, we don't really want to eliminate it necessarily because that could cause some problems. So we'll have to do some refactoring maybe in part 2 to kind of make it a little bit cleaner. But for right now, we'll just hide it. So that way it doesn't cause any issues. In our game manager, we're going to right click, attach a script, and let's just call it game manager.cs. Something that you guys know about me by now, if you've seen any of my tutorials, is that I love game managers. For whatever reason, I've just always enjoyed game managers. I think that they're very useful and good to have in your project. It basically serves as the base of your project. It allows you to have everything right there, and it makes things so much easier. So what I'm going to do here is we're going to keep track of what level we're going to load. So we'll say export public packed scene level 2 load. And then I'm going to go ahead and get node, and we're going to pull back our Nakama client like this, and we're going to go ahead and navigate to that Nakama client. So that's going to be our node 2D. So it's going to be UI / node 2D. Now, normally I would break this off into its own piece, just have it exist, but we'll go ahead and do this for now. And we'll subscribe to that event, and then we'll generate out this function. So I'll hover over it, quick fix, generate that method. So that way that method exists. Now, speaking of that method, when we want to start our game, all we need to do is say var level is equal to level 2 load dot instantiate, like that. And then we can say get node control UI, and then we'll just hide that. So dot hide, like that. And that's going to hide our UI from showing up. So it's going to get rid of this UI so it's no longer showing. And then we'll come in here and say get node 2D, and then we'll say world, like that. And we'll hit dot add child, and we'll pass in our level that we are doing. And that's pretty much all we need to do to get our start game to work. So now the question is this actually going to even come close to working? And my guess is probably not. It never does. It never works the first time, but we can try it and see what happens. So if we click on our game manager and we click on our build icon, you're going to see that it's going to build here, and it's going to save everything. And actually, we should probably save our game manager as well, and our test scene as well. So you'll see we have a level to load. So we'll grab our test scene. That's going to be our test level. That's going to be the level that we're going to load and spawn our players. We're going to go into our test level. We'll click on our scene manager. You can see it requires a player, so we'll drag our player in there so that way our player can be spawned. So now, in theory, if everything just works, it will work. I'm going to doubt that it's going to work, but we can definitely try. So let's see what happens. Well, first things first, it's blank. I'm assuming that that's has to do that we don't have a camera. This is a node 2D. So let's change our test scene node 2D over to a control node. I probably should have made that a control node at the beginning, but that was my fault. And we'll just call this main UI, and I will save that. Now it's going to cause problems with the script that we have. We're going to need to change what it inherits from, and that's okay. So we'll just go ahead and go to our Nakama client. We'll scroll up and we'll change this from node 2D to control because it's a control node now. And then we'll come over here. We will come into our game manager. Let's hit play, providing that it wants to work. We'll make sure that this is out and nice and big. So that way it encompasses the entirety of the thing. That way it's not going to get clipped or anything weird. We'll hit play and see if that fixes it. It might not. It did not. So something's going on here. This is getting subscribed. I'm not getting any errors for that. World is here. I don't need a camera, I don't think. Is it because the UI is not big enough and it's getting clipped? I don't think so. It's possible, though. Yeah, that's interesting. Is there something in here that might be hiding it? Is client being null and then it's queue, or it's not being null and then it's queuing free? That's possible. No, because that should be null. We'll say removing second instance, and actually that should be above this. So we'll do that. Let's see if that's what's doing it. Because if it's just getting blown up because of that, I'm not sure why it would do that.
Yes. So it's getting deleted because of that queue free. So it's saying that client isn't null, which doesn't make sense because client is absolutely null. Oh, I see. I have this backwards. So this, that's why. So this, okay. Okay. I figured out why it's doing that. So this needs to go into here, and this needs to go into here. And it's not going to be Nakama client. It's just going to be client is equal to this. I don't know why I flipped that. My brain just didn't make the connection. So that would be why it's doing that. So we'll go ahead and hit play. There we go. So now we'll submit. We'll log in. We will join test. We'll join test. And then I will click ready. And then I will click ready. Okay. So it started. So that's good. That's good. We got 90% of the way there. We synchronized our stuff. We spawned 2 of them. We're getting a lot of errors. Object reference not set to an instance of an object, but it's working, which is really good. That's exciting. So now the question is, what in the world does this error mean? So object reference not set to an instance of an object. It's saying that on line 36, we have an error with our code. So let's take a look at it. Line 36, if name is equal to info.id. That's because player info is set to null. That makes sense. So we need to basically set this info up correctly. So let's go into our... Yeah, that makes no sense. I understand why it's not working. Okay, so what we need to do is we need to change this to Nakama client.session. So client.session. I think it's .session, isn't it? No. Let me see. If we look at our game manager, let's pull this over. Whoops. Let's pull this over here. Let's take a look at our game manager, or maybe it's our spawning manager. Inside of here, we're setting an ID somewhere. When we do our ready, it must be under Nakama client. We scroll down, session.username. It's right here. And session, I'm assuming, is a private value. That makes sense. So we can't just pull our session user ID that easily. So what I'm going to do is change this to public, because it needs to be public. It needs to be available for me to be able to pull my user ID, which means this needs to get refactored, which is kind of a pain because we have 22 session objects, right? We're going to need to change this to session like that. And I'm curious if I could just right click refactor, rename to session. There we go. That'll work. And now I can go into my character controller and say .session .user ID. And that will make sure that this, actually it'll be username because we're using username, aren't we? So we'll go ahead and do username, and that should hopefully fix it. That means that player info is kind of useless to us for right now, but that's fine for right now. We can play with that later if we want to. If we come in here, we can hit play, and let's see if this even comes close to working. So we'll hit test, join, test 2, submit, join, ready, and there we go. So now our multiplayer is working. Awesome. So really, surprisingly, all that code worked, which is just wild to me that it actually operated properly. But you can see that this guy moves, and then if we click on this guy also moves. So if I move this guy down, you can see that it all synchronizes as expected. And that's basically how we do basic multiplayer. It's really that simple. Now, I know some people have asked me in the past, hey, how can I make my username show up on top of these guys? So I'll just throw that in really quick. If you just come in here and you add in a label like this, you could just come in and add in their username, something like that. You can make it something like this. And then we can basically just come in here, change the size parameter to something reasonable. So we'll just make it small, something like this.
And that will make it so that when the player moves, this will also move with it, right? And then what you can do is you can come in here and basically set this value. So if we come in here, we can go into player, and then we can basically go when the we can go into our scene manager and then basically set their value right here. So we could say player dot get node, and really good coding is going to kill me. I'm not going to let that happen. What I'll do is I'll actually set up a function for this, because it's better to let the player control its information, or the character controller to control its own information. So we'll say public void set up player, like that, string name, and vector 2 position, like that. And then I'll just come in here and say global position is equal to position, and we'll go get node label. And I believe we just have it as label, right, for right now. So label dot text is equal to name. And then we can just come in here and then say in our scene manager, just say player dot setup player, pass in a name, which is going to be their user ID. So that would be their player.name. So that would be this right here, Nakama client player ID. So you can see we're setting this name right here. So this will be perfect, comma, and then the position, which would be the spawn point dot or bracket index dot global. Oh, I'm sorry. It's going to be spawn point dot global position, like that. And that'll set it up in a much better way, because now if you ever need to set up your player, you could just have a single source to set up your player properly. And that way you're not messing around with your scene manager, and it encapsulates your data. So that way it stays with the player and not with the scene manager. And it kind of creates a divide between the two, if that makes sense. So now we can just come in here, go into our game manager, hit play, and it failed to build. Character controller does not contain a definition. That's because I didn't save, so I'll save that. We'll hit play again, and it should load. And now we can just hit that, join, test 2, submit, join, ready, and then ready. Then you can see they now have labels. Now, of course, you can do a little bit of extra work on your end to kind of make it so that it's, centered and all of that. You can use BB codes and stuff like that. And there's thousands of UI tutorials to kind of show you guys how to do that. But this is basically how you create a multiplayer game within Nakama. Now, that is basically how you make a multiplayer game within Nakama. So we talked about how to do basic users. We talked about how to create friends. We talked about how to store data. We talked about how to synchronize data. We talked about how to use multiplayer and matchmaking, all within the Nakama system. Now, Nakama is a gigantic system. There's custom modules. There's an entire system that's dedicated to parties and stuff like that. There's a chatting system and a leaderboard system. So this is not by any means a full, complete tutorial. I will be doing a follow-up, and we will be covering a lot of that stuff. So I will be getting that out as soon as I'm able to. But for right now, this should give you a very good understanding of the base level of Nakama. So if you like this video, go and hit that like button. Hey, if you dislike this video, go and hit that dislike button, because I'm here to make content for you guys. This video was a viewer suggested video. So if you have any suggestions, please leave them in the comments below, or jump on my GitHub. Link is in the description. And if you put in a help desk ticket there, I'll be more than happy to take a look at it and triage it with the rest of my tutorials. And hey, if you have any questions or comments, please leave them in the comments below, or jump on my Discord. Link is in the description, and anybody there would be more than happy to help you out. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.